Hi everyone, and thanks for joining this session. We're going to be looking at understanding the performance of water quality testing equipment and where an innovation-led approach can lead to a drive for improvements. I am Esther Shaylor from UNICEF's Supply Division, and my main focus of work is on product innovation for WASH, and later on in the presentation you'll meet my colleague Johnston from WHO, who will talk you through the lab assessments. Many of you are well aware of the challenges for carrying out water quality testing on site and in the field, especially when there is no lab available. There are long incubation periods to get results, often 18 to 24 hours. There are high risks of contamination when carrying out the testing in the field, and the equipment's complicated and bulky, meaning that it needs quite a bit of training for people to be able to use it. UNICEF and WHO have been working together on an innovation project to stimulate new development of products in this area for equipment that's easy to use, cost effective, $1 or less per test, and offers a time to result within 2 hours. The current activities we've been doing have been working with industry to identify what's currently available that offers improvements in these areas, but also where there's room for innovation and development of new products to reach these goals, to have better fit for purpose equipment. To do this, we've been working on incentivizing R&D with different developers currently acting in the industry and also peripheral to water quality. We have been working since 2017 directly with different industry actors using a target product profile to define what kind of products we are looking for, what we need something to do, but not necessarily how. And then in March of this year, we released a tender for products, mainly culture-based E. coli products, to see where the market was at. And with our partnership with WHO, not only looking at where the products are, but also being able to validate how they perform in the lab. The innovation project has been working with industry and developers to communicate what an improved product needs to do. And we've done this using 3 clear use cases. We have the household surveys, such as the multi-cluster indicator surveys that UNICEF and WHO do jointly. We've used community-led monitoring and emergency response, looking at fluctuations in water quality due to rainy seasons, which lead to cholera outbreaks and so forth, but also utilising water communities that are already in the field. And then lastly, looking at regulation and surveillance. Can we have a much easier and quicker to use product that would allow water utilities to carry out more surveillance in the field and ensure that they have a regular supply of safe water? And by outlining through these different use cases, we've made it clear that the outputs we need are to have something that's cost effective, easy to use, quick time to result, and then would allow us to increase the volumes of testing we can do in order for us to reach SDG 6. So what does an innovation-led approach look like? Well, UNICEF has defined product innovation in 3 phases: need, research and development, and scale. UNICEF actively engages in the first and last stages, need and scale, whereas the R&D is done by developers such as businesses and academia, with UNICEF driving the process. For this particular project, we used a target product profile approach. And this target product profile communicated the types of products that address the needs identified, with inputs from partners, the technical advisory group, and country offices. The TPP was then used as the basis for the tender for this project, and that will allow us to evaluate the market-ready products that go some way to reach the desired specification outlined. And then we hope to use a co-creation approach with industry that enables us to guide the more novel technologies to ensure that they can be used and they are appropriate for the use cases outlined in the target product profile. And then lastly, within the innovation approach, if we feel there is a need, we can look at using appropriate incentives such as push and pull mechanisms to drive the R&D faster to reach the kind of products that we're looking for. So after the tender last year, we had 18 products submitted, of which the majority were unsuccessful in that they didn't offer any improvement in time to result or ease of use. We had 6 products that offered a possible improvement in ease of use, but not in the time to result. And then we had 2 products which were invited to go further in the tender process. Now, these two products offered us improvements in time to result, but still over 6 hours, between 9 and 6 hours, in fact, was what was submitted. The next part of the tender process was to validate this, and this is being done in 2 phases. The first phase is lab validation, and the second phase is field validation. The lab validation is being led by WHO, and my colleague Rick is going to share his experiences of the results so far. At the same time of validating these 2 novel products, WHO have undertaken a wider evaluation of products for water quality testing. So Rick will cover all of that. But the results have been interesting, and what it allows us to do is to know that the products we're buying and proposing to use in the field actually perform in the way in which we want them to enable us to do more water quality testing. We also recognise that culture-based processes can only get so fast. But the lab validation also allows us to better understand the timings and the use cases, recognizing that it's never going to be one water quality testing product that's going to suit all situations. Understanding how they perform in the lab under different challenges gives us a greater understanding of how the products perform, so we can better advise each use case and colleagues towards the right products.
Hi, I'm Rick Johnston. I manage the WHO side of the WHO UNICEF Joint Monitoring Program for Water Supply, Sanitation, and Hygiene, or JMP, and I'm going to talk to you about an assessment of portable kits for E. coli testing that the JMP has been conducting. This assessment process has actually gone on for several years now. Back in 2019, or even a little bit before, we started developing a protocol to assess E. coli tests in labs. We reviewed other protocols, we convened and consulted with a technical advisory group, and then in early 2020, we selected a laboratory, which was KWR in the Netherlands, following a public call. Then we selected which kits we would assess. They fall into 2 categories of suspensions or colony countings, and then put those kits through 2 phases of challenges. In the first phase, we worked with lab strains of E. coli and did dilutions, serial dilutions from very high concentrations down to below detection, and would also incubate at 1 or 2 temperatures and durations depending on the kit. In the second phase, we moved from lab E. coli to wild E. coli and use natural waters, and also add some non-target organisms that are not E. coli but might possibly interfere with the analysis. And depending on the kit, we'll look at a more extended range of temperatures and incubation periods in phase 2. So we ended up selecting 20 kits to assess. About half of them were based on colony counting. So 9 membrane filtration kits and 1 using a gel medium where you can still count the colonies. And then another 10 were suspension methods, where it might be a presence-absence test where you have a 100 milliliter volume that turns color. We turned those into quantitative tests by putting them in small wells, so we could calculate statistically the most probable number. And other kits had their own proprietary most probable number set up, or had some other method of quantifying fecal contamination. About 5 of these, 1/4 of them, counted as novel products that were either still in development or recently developed. Now, the first phase of assessment has been completed for those 20 kits. And what we found was, we found some variable recovery of E. coli. Often we found the membrane filtration methods gave lower counts than some suspension methods, or different methods would give lower counts than the reference method. We used the IDEX Quantitray 2000 as the reference method. And especially some of the newly developed novel products had some quality control problems. So we ended up selecting 14 of the 20 to go on to phase 2 challenges. So 2 of those novel products weren't selected because of those quality control problems. We also didn't select 2 commercially available presence-absence suspension media. And there was 1 commercial plate that we didn't choose to move ahead with the 1 milliliter formulation where you count colonies directly in 1 plate. But we will still work with that commercial plate with the membrane filtration setup. And here's just an example of the kind of results we have comparing the reference method on the x-axis to the trial method on the y-axis. On the left, you can see one of the novel suspension media called resirufin. did really well. The slope was almost perfectly 1. It had high correlation coefficients, so we're definitely taking that one to phase 2. But on the right, you see another suspension method commercially available called Aquachrome, ECC, where the correlation was good. Pearson's R, Spearman's R were above 0.9, but the slope was significantly lower than 1, indicating lower recovery. So we chose not to move ahead to phase 2 with a few tests for those reasons. So phase 2 results are still preliminary. The laboratory is actually still doing the phase 2 testing. We've not found any serious problems so far with non-target bacteria. So if you add a lot of things other than E. coli, like Aeromonas or Pseudomonas, a few products have low-level positives where there shouldn't be any. Or if you add those things along with E. coli, sometimes you get reduced recovery of E. coli. Not surprisingly, we found that at lower temperatures, at 20 or 25 degrees Celsius, we see slower growth and lower recovery. We also found that at high temperatures, we have lower recovery. So especially some of the kits might not be suitable for very warm environments. And the wild E. coli and the natural waters will be really interesting. Those are coming soon. We haven't started those yet. So for next steps, the phase 2 testing is almost done, so we need to complete that and publish the results later in this year. But what we'd like to do is then follow that with a second round of testing, including more novel products. And we'd also like to look at products that don't simply measure E. coli through culture-based methods, but have some really innovative or novel ways to quantify fecal contamination. So watch this space for our next round of testing, hopefully later this year or into next year. Thank you.
So what happens next with this project? Well, the results from the lab testing will be concluded and reviewed. And we'll do this with our technical advisory group that's made up of a variety of experts from this sector. And we'll decide what to do with the novel products in terms of field testing. The results for the other products that we test in the lab will also be shared wider for the sector to understand. At the same time, the innovation project work is further trying to understand non-culture based methods which could be used for field testing that may be relevant in the use cases. These include the use of qPCR, different biosensors that act as proxies for E. coli, RNA-based testing, or tryptophan-like fluorescence. There are a range of technologies that just haven't been used in these use cases previously. And we need to further understand the pros and cons, the challenges, and how we validate, how we ensure that we have a reference method, such as we're using in the lab for the culture-based approaches, that would allow us to know that these products perform, and we can say that they are the right products for what we want to use them for. At the same time, UNICEF is also looking at how we influence the market, how we continue to engage with industry and incentivize them that this is a market worth investing in and to develop products that meet the needs outlined in the target product profile. Once we have that, we can look at how we validate, as I said, these products, especially the novel technologies that just are really new, not just to us, but to the sector in general. And then hopefully we can look at doing another tender for these rapid products, and we can really strive to get those cost-effective, easy to use and quick products so that we can see wider use of water quality testing across the sector. That's it for now. So thank you very much for your time. And if you do have any questions, please do reach out to myself or Rick. Thank you.